All right, this video is for the lesson 4.9 homework. So this is last day of domain and range. We're looking at real world situations. So when we're doing domain and range of actual real world situations, we got to think, is it realistic? Could it happen? Kind of stuff. I'm going to work this one kind of different because I want to work through both examples with you. So I'm just going to work a few of each type because you should know how to write the domain and range in all the different forms by this point. All right, number one, what is the name of the x-coordinate of a point at which the relation crosses the x-axis, meaning the y-coordinate is 0? If y is 0, we're talking x-intercept. And then number two, what's the name of the y-coordinate of a point in which the relation crosses the y-axis, meaning the x-coordinate equals 0? This is the y-intercept. So when the y is 0, we're talking about the x-intercept. When the x is 0, we're talking about the y-intercept. All right. What is the domain and range of the area in inches of a rectangle with a length of x plus 7 and a length or width of x minus 8? So we've got a rectangle. Thank goodness for that. X plus 7. And then this one is x minus 8. Are there any values of x that I cannot use? Okay, negatives. If I'm finding the area of this rectangle, how do I phrase that? Are there any, so they're never going to be negatives, but what else will the side lengths never be? Can you have a rectangle with a side length of 0? No. So, what value of x would make this side a 0? 8. So, for this side, x has got to be greater than 8, right? Can't be 8, but just a little bit more than 8, and we're still okay. What about here? Negative 7. So x has got to be greater than negative 7. So we've got to take all that information and pick which value works. So if I say the domain is greater, as long as x is greater than negative 7, will that work? Can I plug a negative 7 in here? No. No, because negative 7 minus 8 gives me a negative side length. So I can't use that parameter. All right, can I use the parameter x is greater than 8? Can I plug an 8 in here and this still be a valid side length? 8 plus 7, that gives me a positive number. So then that's my valid domain. So all real numbers greater than 8. What about my range? So my range is going to represent the area of this rectangle. What values can area not be? So can't have negatives. Can area be a 0? Okay. So no negatives, no zeros. All right, let's go through the sets of numbers. Can area be a fraction or a decimal? Yeah, I mean, you could measure a half, have a box that's a ½ inch by ½ inch, and that would work, okay? So that covers rational numbers and everything. What about a square root? Could I have a rectangle? Can I have a rectangle where the area is like 2 times the square root of negative 2?
Yes.
Yeah, I mean, if this side is 2 and this side is the square root of 2, so that covers irrational numbers. So all the rational numbers, all the irrational numbers, means we're talking real numbers. With the parameter, it's got to be greater than 0. So all real numbers greater than 0. All right, in interval notation, that's the brackets and the parentheses. How do I write all real numbers greater than 8? All real numbers greater than 8. What's my starting point? 8. Start at 8, but don't include 8. What's my end? Infinity. All right, does the 8 get a parenthesis or a bracket? Parenthesis, because greater than, not or equal to. What about infinity? Always. All right, in interval notation, how do I write all real numbers greater than 0? Start at 0, go all the way to infinity. Both are parentheses. All right, I don't know why. Inequality is the easy one to me. It's just easy to go from words to the inequality. All real numbers greater than 8. So x is what we're talking about. Has to be greater than 8. Same thing here. All real numbers greater than 0. X has got y is greater than 0. I do that. I do that so often. A girl that I had in Merkel, she's 2 years older than y'all. I think she still works at Target. She's going to college too, but I see her at Target. We had our own language in Merkel, and now it was Akabaka, and we could communicate to each other. So it still comes out occasionally. All right, set builder notation. I take the set we're talking about, real numbers. So x is a member of the set of real numbers, and then I tack on the inequality. Okay? Set notation, the set of numbers and the parameter of that set, or the inequality. So this one would be y is a member of the set. Lord, my brain stopped. Of all real numbers where y is greater than 0. So when you're talking about rectangles in area, find your two values. This side, it can't be this. This side, it can't be this. And then decide which of those two numbers doesn't work for either side. And that's your starting point. If you're talking about area, it's always greater than 0. As long as your area, as long as your y is greater than 0, you're good. Here's where you guys are at a disadvantage. If you did not have a complete quadratics unit, this is going to throw you for a loop because you're not going to understand what the pieces mean. All right, projectile motion or quadratics. So a cannonball is launched from a platform. The function h of t equals negative 4.9 t squared plus 19.6 t plus 58.8 can be used to model the cannonball's height after t seconds. What's a reasonable domain and range? Yeah. This one is easy because it gives you this, but I just want to show you some pieces of projectile motion. So if I've got a platform, right, and I launch a cannon off this platform. Okay? It's going to travel like this and hit the ground. Okay? Just off the equation, there's a couple things that I know. The last number of a quadratic is your y-intercept. So I know that this cannon is 58.8 feet off the ground. The vertex, so the vertex, h comma k. H tells me the time that it reaches, so the x value, its highest point, and then k will tell me what the highest actual point is. And then finally, this is the ground. Where it hits here, this is an x-intercept. The x-intercept will tell you how long that cannonball took to hit the ground. Projectile motions are used a lot in quadratics, okay? Just giving you some pieces so you've got some background information. This one's a little bit easier though. I can take this equation and I can plug it into the graph. That is not what I told you to do. All right, so we've got, and I use x instead of t, so negative 4.9 x squared plus 19.6x plus 58.8. I can zoom out, menu, zoom, 4. I can kind of see what it looks like. I want to show you another cool feature of these calculators. If you do menu, 4, and then box, you can kind of select just the portion you want to be looking at, and it gives you a better view. All right, so going off of the picture and going off the picture that I drew. So this is my x-axis, right? And then this would be my y-axis. For this scenario, what's the lowest x value I can have? X represents time. Can time be negative? So what's the x value right here when this thing is shot? 0. So I'm starting at 0. Where would my x's end when I'm talking about real world here?
0.
Time.
Oh, the x is time?
Yes. So where it hits the ground here. So what should I look for? I need to look for the x-intercept. So I know my first value is 0. The time starts at 0. The time stops when this bad boy hits the ground. So on the graph, I can do menu, analyze, 0, and I want this far x-intercept. So that far intercept is 6, 0. So right here, that point is 6, 0. This point here is 0, 0, or yeah. So verbally, how would I say my domain? Can an x be, can it be 0? Can it be equal to 0? Yeah, and that would give me the height of the cannonball before that cannon's launched. So we know we can include 0. Okay, so all real numbers greater than 0. Can the x, can it be a 6? 6 is included. That is when that ball goes and it stops. Okay, so 6 is a value in the journey of this cannonball. So in words, all real numbers greater, and I'm just writing shorthand, greater or equal to 0 and less or equal to 6. Your job is going to be to write that in the different forms. Greater than or equal to 0, less than or equal to 6. All right, my range, my y value. So my y value, I'll put this back up. My y value, we're talking about height. So what's the lowest that this cannonball can get? Ground. What number represents the ground? So 0. What's the highest this cannonball gets? The maximum, right? This is the starting point, this 58.8. I need to find the vertex. Okay, so same thing. On this graph, menu, analyze, and it's a maximum. Book, book. And it's the y value, 78.4. So that's the highest it gets. So is 0 an actual solution? Can the cannonball be sitting at 0? Okay, so that would be a solid dot. Would 78.4 be a solid dot? Remember, if it's in the middle of the line. So my range would be all real numbers greater or equal to 0 and less or equal to 78.4.